Okay, reflection is the first chapter under coordinate geometry. That means everything to do with graphs. Okay, it's a graph chapter, but you don't need graph. Okay, you might need towards the end of the chapter, okay, to make it easier, but most of the questions in this chapter can be done without a graph. Okay, all right. So the word reflection means what? We have seen the word reflection in physics, right? Reflection on a plane mirror, reflection on a curved mirror. Here we are going to see reflection on a line. Okay, a point reflecting on a line, and the line is going to be either horizontal or vertical. Horizontal or vertical, not any diagonal line. Okay, so that diagonal line reflection will be very difficult. You're going to see a reflection on horizontal lines and vertical lines. Okay, now if you look at a graph, you have two lines. What are those two lines called? Huh? The x-axis and the y-axis. Yeah. So let me draw. What am I drawing now? This is what? The, and here I'll draw the x-axis. Okay, so let's mark some points on this graph. So what is this point called? This will be 1, 2, 3, 4, 5, 6. This is the positive side of the x-axis. Then on the left side you'll have -1, -2. And then on top if you go, this is the y-axis. So 1, 2, 3, 4, 5, 6, and so on. And if you go down here, -1, -2, -3, -4, -5, and so on. Okay. Now these, if you have the positive and the negative uh, axis, we call that, what do we call it? If you have both positive and negative, see, in some graphs you'll only have this much, only the positives. Right? We draw this for histogram and frequency polygon and all that. We only draw the positive part. Okay, but here we have both positive and negative. So this is the type of graph that we're drawing for this chapter, right? The graph that has both positives and negatives. Now, point. Any point on the, do you know how to call, name any point on this? Let me write a point and you tell me what is the name of that point. What is this point? 2, 5. Right, 2 on the x-axis. Saman, you didn't tell me. And 5 on the y-axis. Okay. Now this point can be reflected. Chapter is reflection. So this point can be reflected at different places, at different planes or different lines. So we can reflect it along the x-axis. Okay, let's do that first. So what will this point be if you reflect it along the x-axis? Imagine the x-axis is your mirror. So where will this point be?
So it will be 2, -5.
Yes, it will be over here. That is 2, -5. Okay, so whatever distance it is in front of the mirror, this is like a mirror. That same distance you have to look behind the mirror. Got it?
Yeah.
Okay. So basically, what is happening to 2 and 5? It's becoming 2, -5. So which value is changing? The
So
x or the y coordinate? The y coordinate is changing sign when we reflect the point on the x-axis. See, when the point is reflected on the x-axis, the y-coordinate sign is changing. You noticed it? Okay. Now let's do the same thing. We'll reflect this point 2, 5 on the y-axis. So when you reflect 2, 5 on the y-axis, what will it become? -2, 5. You see -2 on the x-axis and 5 on the y-axis. So what did you notice here? When you're reflecting a point on the y-axis, the x-coordinate is changing sign, x-coordinate. I'll say that once again. When you reflect a point on the y-axis, the x-coordinate is changing its sign. And this side down, if you reflect a point on the x-axis, the y-coordinate is changing sign. Is that clear, everybody?
Yes, sir. No, we
So
call it abscissa and ordinate also. No?
yes, I was just going to say that the x coordinate is called what? Abscissa, and the y coordinate is called ordinate. Okay, so that's the word you'll be seeing more often here. The x coordinate is called abscissa, and the y coordinate is called ordinate. Okay, next we are going to see, so we have seen two reflections, one on the x-axis, one on the y-axis. Third is reflecting of this point on the origin. So origin is a point, and we're going to reflect this on the origin. So from here through the origin, where will it go? Here. So what is the coordinate of this point?
Minus
-2,
minus
-2, comma
Minus 2,
-5.
minus 5. So what did you notice when a point reflects on the origin? Both
change.
change sign. The abscissa and the ordinate will change signs. This is 50% of the chapter. Half of the chapter is over. What? Ryan, you're saying something? Your mic is not good.
Sorry,
Okay.
my mic was.
Yeah. Okay. Just rejoin the meeting, and while you're rejoining, just draw this diagram till then. Okay. Draw this x and y axis. Mark the point 2, 5. Show its reflection on the x-axis and reflection on the y-axis and reflection along the origin. So what we saw till now is that if any point reflects on the x-axis, like for example 2, 5 will become 2 minus 5. So that means its y value, its y coordinate or the ordinate is changing sign. Okay. Then if the same 2, 5 reflects on the y-axis, then the x coordinate is changing sign. That is 2, 5 becomes minus 2, 5. And third, we saw that if a point reflects on the origin, that is at this midpoint here 0, 0, then both the signs are changing. 2 and 5 both will become minus 2, minus 5. Yeah, abscissa is the x coordinate and ordinate is the y coordinate. Okay, now coming here. So here they've given a point 5, minus 7, and it became minus 5, 7. So here both x and y coordinate have changed signs. So that means this reflection is on the, if right over there, reflection in origin. Okay, next one 4, 2, reflection on the x-axis. So what will this become?
4,
minus
Minus 2. Only the y coordinate will change sign. Next, reflection on the y-axis. So the x coordinate had to change sign. X coordinate is 0. 0 cannot change sign. 0 will be 0 only. Right. So this is 0, 6. So this is one important thing. Okay.
Our teacher told us to write that it's invariant.
Yeah, I was just going to say that. Okay, good. You know it. You're remembering it. So if a point after reflection does not change its value, that point is called invariant. Invariant means even after reflection, its value does not change. For example, look at 0, 6. After reflecting on the y-axis, the x coordinate had to change sign. But what do you mean changing sign of 0? It will become minus 0 or what? No, right? So 0 will remain as 0. So that means if any point lies on a line, it will not change after reflection. Let me give you an example. Okay, now here, look at this axis. This is the x-axis. Now, if there's a point here, what is this point here? Let me get right here. Okay, okay. This point is what? 4,
4,
1. After reflection on the x-axis, what does it become?
4, minus 1.
Minus 1. Yeah. So here, after reflection, the y value had to change, and it changed. Sign changed. But what if this point was on the x-axis, like over here? What is the coordinate of this point here? X value is 4, y value is 0. So 4, 0 this point is. Now if this point reflects on the x-axis, what is it going to be? It's going to be right there only. It's like if there's a mirror and you put something on the mirror, where will its reflected image be? It will be right there only, right? So such a point which does not change after reflection is called invariant. Understand? So 4 comma 0 after reflection on the x-axis, what will it be? It will be 4 comma 0 only. It will not change. That is called an invariant point. Is that clear, everyone? Okay, next. 6 comma minus 6 became minus 6 comma 6. So that is
Sorry.
oh, next. Here the x coordinate,
Y-axis.
that means reflection on the y-axis. Everyone clear on this?
Yes, sir.
Okay. See this second question. A point P is its own image under the reflection on a line L. Describe the position of the point P with respect to the line L. There's a point P. It is reflecting on a line called L. But even after reflection, what happens? A point P is its own image. That means its image is also the same. That means what? Huh? Not on the origin. Or origin means both x and y will change, no? It's on the line. Any point on the line is invariant. Invariant means it will not change. Right? You understood, everyone? You're not understanding. You got it? Did you all understand? Look,
Yes.
this 2 comma 5 we'll call it the object, and this we'll call it the image. The word object is not used very often here. In physics we use object and image, but here we don't use the word object, we use the word image. Okay, so here you can see object and image is not same because the point is not on the mirror. But what about this 4 comma 0? It's on the mirror. So even after reflecting on the mirror, what is its reflection? What is the image? Same 4 comma 0. Okay, so any point on the mirror is invariant, means it will not change after reflection. Now let's read this question again. A point P is its own image. It means the point and the image is the same under reflection in a line L. Describe the position of that point P with respect to the line L. So the answer is what? Point P lies on the line L. Yeah. Next, state the coordinates of the following points under reflection in the x-axis. Okay, reflection on the x-axis. What will this become? 3 comma 2?
3 comma minus 2.
Minus 2. Minus 5 comma 4?
5 comma minus 4.
Minus 4.
I didn't understand the third question.
Reflect the point on the x-axis. So the y coordinate will change. Right?
Yes, so we have to choose any one from these three.
No, it's not choosing one, it's not MCQ. Each one has there are 3 different questions. You have to reflect each point. So just change the y coordinate of these points. Last one 0 comma 0. 0 comma 0 only, because the 0 when you reflect change the sign, it's going to be 0 itself. Next, fourth question, I'm going to tell this is reflection on the y-axis. So what will 6 comma minus 3 become?
Minus 3 comma 6.
Minus 6 comma minus 3.
Hey, don't interchange x and y value. Ahmed, 6 comma minus 3, you have to write like this, under reflection on the y-axis. Its x coordinate will change sign. X coordinate is 6, so it will become minus 6. The y coordinate will remain the same. Okay. Next, minus 1 comma 0. What will this become?
1 comma 0.
Minus 1 comma minus 0.
Hey, minus 1 will become 1. On the y-axis, the x coordinate will change sign, Ahmed. When you reflect a point on the x-axis, when you reflect a point on the y-axis, the x coordinate will change sign. Means minus will become plus or plus will become minus. Ahmed, tell me the last one. Minus 8 comma minus 2. What will this become?
8 comma minus 2.
8 comma minus 2. Clear, everybody? Fifth one, reflecting the point on the origin. So on the origin, what happens? Both the signs will change.
Both sides change.
So minus 2 comma minus 4 will become
2, 4.
2 comma 4. Next, minus 2 comma 7.
2, minus 7.
Minus 7. 0 comma 0. 0 comma 0. There is no minus 0. Right? Okay. Is this clear? Any doubt in this? Okay. Now, a small modification. Your x-axis, this is your x-axis. X-axis is also called as y equal to 0. You know that? You remember this? It was there before. Now, why do we call this x-axis as y is equal to 0? Because any point on the x-axis, here we have one point on the x-axis. Look at the coordinates, 4 comma 0. You see the y coordinate? What is it? 0. What about this point here? What will this point be? 1 comma 0. What about this point here?
That's what.
Minus 4 comma 0. What about this point here? Minus 6 comma 0. So you see at every point on this line, the y coordinate is always 0. That's why this line is called y is equal to 0. Is that clear, everyone? Okay, so this line, this blue line here is called y is equal to 0. What if I move this line up here? What do you call this line now?
Y is equal to 1.
Y equal to 1.
Y is equal to 1 because it passes through the point 1 on the y-axis. So every point on this line, the y coordinate will be 1. Okay, now if I move it here, y is equal to 3. If I move it down here, y is equal to minus 4. Okay, so anyway, we'll come to that later on, but you understood how it is. So this line here, if the line is on the x-axis, we call that line as y is equal to 0. So sometimes in the question, they will not say like here, reflection in the x-axis. They'll say what? Reflection in the line y is equal to 0. Did you see the seventh question here? They're saying write down the reflection under the line y is equal to 0. So you need to understand that y is equal to 0 is same as x-axis. Clear, everybody? So x, another word for x-axis is what? Y is equal to 0.
Y is equal to 0.
Similarly, another word for y-axis is
X equals to 0.
okay. So tell me the sixth question. Reflection in the line x is equal to 0. So x is equal to 0 means y-axis. So what is minus 6 comma 4 after reflection?
6, 4.
6 comma 4. The x coordinate will change, you know, when reflection on the y-axis. 0 comma 5.
2, 5.
0 comma 5. This is an invariant point. And 3 comma minus 4.
Minus 3, 4.
Minus 3 comma minus 4. Okay, I think you got the point. So now we are actually done with half of the chapter. Okay.
46 one.
What?
Sixth one.
Sixth one, that's the line x is equal to 0. X is equal to 0 means the y-axis. So reflect all these points on the y-axis. That means that x coordinate will change. Okay, look at this 10th question here. The point P, A, comma, B is first reflected in the origin and then reflected in the y-axis to P dash. If P dash has the coordinates 4, comma 6, then evaluate A, comma B, A and B. Okay, so first this point P, whatever it is, we don't know it is A and B. Okay, I'll write it here, A, B. Write it here, A, comma B. First you're reflecting it how? On the origin. So then it becomes something P double dash, we'll call it. Okay, and then you're reflecting this where? In the y-axis. And then it becomes what? P dash, and they've given the coordinates of P dash, which is 4, 6. Okay, so they're asking you what is AB. So we need to work our way backwards. Okay, so first on reflection on the y-axis, what is 4, 6?
Minus 4,6.
Minus 4, 6. Correct. We'll look at it forward now. So minus 4, 6 became 4, 6. Now backwards. So
4,
what is
minus.
4, minus 6? Because you're reflecting on the origin. So this is A and B. A is 4 and B is minus 6. That's your answer. A is equal to 4, B is equal to minus 6. Clear how to do this? So it's very simple, no? Just seeing where it is reflecting and changing the signs. Write down this 10th question and see in your book what is this number. Do this 12th one. 12th one. The point A minus 3, 2 is reflected in the x-axis to the point A dash. Then point A dash is reflected in the origin to point A double dash. Write the coordinates of A double dash. So now this is not backward, this is forward only. A first is reflected to form A dash, and then that is reflected to form A double dash. The question is, what is A double dash? We know A's coordinates minus 3, 2. So complete it. Tell me what is A double dash.
No, A double dash is 3, 2.
Okay, let's see. Anyone else?
3,2.
Success.
Aman, did you start? Yeah. You finish? You need to be fast. So first reflection on the x-axis, it will become minus 3, minus 2. And then reflection on the origin, that time that will become 3, 2. Right? That's the first answer. Second one, write down a single transformation that maps A onto A double dash. So from here to here directly, what is the reflection?
Y-axis.
Y-axis.
The y-axis. Because the x value is changing, minus 3 is becoming 3. So this A to A double dash is a single reflection on the y-axis. Clear? Write it. Next, 14th question. The triangle ABC, where A, B, and C are 3 different points, is reflected in the y-axis to another triangle A dash, B dash, C dash. Then that triangle A dash, B dash, C dash is then reflected in the origin to a triangle A double dash, B double dash, C double dash. So instead of 1 point being reflected 2 times, you have 3 points being reflected 2 times. So what they're asking, what is the coordinates of A double dash, B double dash, C double dash, and also write down a single transformation of ABC onto A double dash, B double dash, C double dash. So exactly like what we did in the 12th, but it's not 1 point, it is 3 points. Okay, so you do separately for A, B, and C. Should look something like this. Then for B and for C.
2, dash.
So what's the final answer? A double dash, B double dash, C double dash?
A double dash is 2, minus 6. B double dash is minus 3, minus 5. And C double dash is 4, minus 7.
Okay, so what is the single transformation that took place?
X-axis.
Reflection on the x-axis. See a pattern here. If the reflection is first on the y-axis and then the origin, the total reflection is on the x-axis. See in the previous one how it was? First reflection on the x and then second on the origin. So the total reflection was on the y-axis. So the pattern XO is Y, and here YO is X. Notice that? Not important to notice, but yeah, if you notice, you notice it. Right, so this is your final answer for the first one. Second one you should write, it's a single transformation. The single transformation is a reflection on the x-axis. The single transformation is a reflection on the x-axis. See how they can ask you questions here. See, this is similar to what you just now did. If you're drawing it on the graph, sometimes you'll have to draw this on the graph. So here you see where's ABC. Here you see ABC. It's a triangle. So first they're reflecting ABC on, no, here A dash B dash C dash. So reflection on what? How did this come here? Reflection on origin.
Origin.
And then from here to the right side. So this was reflection on the y-axis. And then the single transformation is a reflection on the x-axis. Okay, then they'll ask you to join some points. For example, they'll tell you to join B, C, C double dash, B double dash. These 4 points. And after joining these 4 points, they'll ask you what shape are you getting? So what shape are we getting here? It's a trapezium. Right, trapezium has 2 sides parallel to each other, other 2 sides not parallel, not equal to each other. So you're getting a trapezium. Then sometimes they'll ask you find the area of the trapezium. Okay, so you know what's the formula for area of trapezium? Anyone knows? Formula for area of trapezium? It's something that you have studied before, so they don't teach you in 10th. It's half into sum of parallel sides
Yes.
multiplied by the distance between them. So here in this case, which is the parallel sides? B, B double dash and C, C double dash. That is this parallel sides into the distance. What's the distance between them? So that you'll have to count. See, this is at 4, this is at 7. So 4 to 7, what's the distance? 4 to 7. 3. How do you count 4 to 7 is do 7 minus 4. Okay. Even if you're putting the values here, B, B dash will be how much? B to B double dash. So B is at which number? Say it's at 5. B is at 5 and B double dash is at minus 5. So what's the distance from 5 to minus 5? 10. 5 on the positive and 5 on the negative. If you're still not getting 10, you just have to do the big number minus the small number. You'll get the answer. What's the big number here? 5. And the small number is minus 5. So 5 minus 5. Big number minus small number. So 5 plus 5 you'll get 10. Okay, so that is B, B double dash. Plus, what is C, C double dash? Look at the diagram and tell me. 4. 2 on top, 2 down. So 4 into 3. So that is 1 by 2 into 14 into 3. So 2 and 14 we can cut. So answer is 21. 21 what?
21.
It's area. So normally area we call it centimeter square, meter square. That square has to be there. But here we don't know whether it is centimeter or meter or kilometer. So we have to say unit square or square unit. So SQ unit, square unit. Okay, that is how you write the unit. See here, 21 square units. Okay. So depending on what shape you get, you have to use that particular formula. If you get a rectangle, very easy, length into breadth. If you get square, more easier, side into side. If you get parallelogram, what's the formula of area of parallelogram? This is a parallelogram. What's the area of parallelogram? Base into height. This is base. Height is a perpendicular distance between the two parallel sides. Okay. So like these formulas, you have to know it. How's reflection chapter? This first part is easy. Second part is a little more tougher that we will do in the next class. Okay. I hope you remember or you wrote down the formulas for this. There's tomorrow you'll forget. This is area of, write down, area of trapezium.
No, but I didn't understand the formula area of trapezium.
Okay. Area of trapezium is half into sum of the parallel sides. These are the parallel sides. B, B double dash, C, C double dash. Multiplied by the distance between them. Distance between the two parallel sides. Perpendicular distance. Did you get it or not? If I'm drawing a trapezium here, A, B, C, D. So what's the formula? Half into, which are the parallel sides here?
A, B, and B, C.
So sum of that is AB plus CD multiplied by,
Region
no, multiplied by the distance between them. So here we'll call it height h. So multiplied by that h. That is a perpendicular distance between the two parallel sides. Is that clear? Everyone clear of this
Yes.
formula how to find area of trapezium? Come on. And parallelogram is base. Here also height is perpendicular to the base. Remember that. This is not the height. Can this be the height here? No, that's not perpendicular. It is sideways, no? Okay, all right. Homework. Show your textbook. Open the chapter. Ouch. Open fast. I'll give you homework. Please do that homework. I'll put it on the group. Where's my phone? I'll send you the homework on the group, okay? The question number and the page. So those of you who don't have books, don't need to worry. Okay. I'll put it up on the group. Okay. All right. See you all tomorrow. Bye.
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 So in the last class, what we saw was we were reflecting a point on three different planes or lines. First, it was on the x-axis. We reflected a point on the x-axis, like for example, 2, 5. When reflected on the x-axis, the y coordinate changed, right? And it became 2, minus 5. Then we reflected the point on the y-axis. And that time what happened? The x coordinate changed the sign. Then third one was reflected the point on the origin. And that time what happened?
Both the axis and ordinate changed.
Abscissa and ordinate had a change in sign. Okay, now fourth and fifth, we have two more reflections. Now before that, we also saw that the x-axis is also called as what? The x-axis is also called as y equal to 0. The axis, not the coordinate. The line, the x-axis is called as y is equal to 0. Okay. Now what we're going to see is, what if this line is not passing through the x-axis or the y-axis? What if it is over here? You saw this? Now what do you call this line? Y is equal to 3. Correct? Now what if this point 2, 5 reflects on this line y is equal to 3? Where will its reflection be? Understood the question, everyone? You have to just use logic and calculate. Think of this line as a mirror and figure out if this is the point 2, 5. If it reflects on this line y is equal to 3, where will its reflection be? Tell me. So this point is 2 units front of the mirror. So the image will be formed where? 2 units behind the mirror. Here, right? When anything is in front of the mirror, how much in front of the mirror it is, that much behind the mirror only the image will form, right? So there's no formula or anything here. Here you just have to put the value on the graph and then calculate, okay, how many units forward, that many units backward, like that. Did you get it? So this 2 comma 5 when reflected on this line, what is the name of this line? Y is equal to 3. Where will the image be formed? Right behind the mirror. So what will be the coordinates of this point? 2 comma 1. So no changing sign. It's more complex than that. The numbers only change. You notice it?
No, I did not understand.
Okay. See, this is your point. We'll call it P. The point P is in front of the mirror. This y is equal to 3 is the line at which it's going to reflect. It's like the mirror. Okay. So you see this point is here, 2 units in front of the mirror. So the image will be formed where? 2 units behind the mirror. Correct. So you mark the point and then you find out what the coordinates of that point is. Got it, everyone? I know you got it. Okay. Now I'll give another point, another line. Sorry, a little far away now. Say this line. Okay. The name of this line is y is equal to -2. So what will be the reflection of this point 2 comma 5 on the line y is equal to -2? So again, you just have to count.
6 points going down.
So how many units front of the line is this point?
6.
Not 6.
7.
7, Amma.
7 points, right? See, because 2 down and 5 up. See, from the x-axis you count. 5 units up, that's why 5 here. And this is 2 units down. So that's totally 7 units above the mirror. So the image will be formed where? 7 units down here.
-9.
Yeah, it will be at -9 because this is -2. And then 7 units down from -2, you go 7 below, then go to -9, right? So the coordinates of the point, the reflection will be what? What will be the coordinates? Tell me the x and the y coordinate.
1.
The 2 will remain as 2. See, when when a point reflects on a line that's parallel to the x-axis, the x coordinate will not change. That 2 will remain as 2. Only the 5 will change to -9. So that will be what? Somewhere here down below this, 2 comma -9. -7, -8, -9. So here the point is there is 2 comma -9. Okay. Now do we need a graph for this? Yes, it helps, right? So you can see, because to do these type of reflection without graph, it's going to be very difficult. That is, you have to have very good sense of imagination. Or best thing is, if they don't give you a graph for this, you have to draw a rough diagram like how we're just drawing. Okay, without a graph paper, you can draw a rough diagram and then you can just count how many units up, how many units down, and then you can draw the reflection. Is that clear, everyone?
Amma, there is no need to show it on a graph, right, in exam?
Yeah, you might not get a graph for this question. Like they only give certain graphs for certain questions. So for this question, you might not have a graph. So you have to just draw a rough diagram on your answer sheet itself and count upwards. Okay. So I'll
Okay,
give you
thank
some
you.
questions. Yeah, I'll give you some questions like that you can tell me the answer for. Okay. So I'll give you a line over here now. Okay. So they'll tell you what the line. Oh, wait, I won't draw the line actually. I will tell you the name of the line. Okay, and you have to tell me where the line should be drawn and tell me its reflection. Okay, so the line is called x is equal to -1. How do we draw that line? X is equal to -1. Is it vertical or horizontal? Vertical.
Vertical on -1.
Yeah, so it passes like this, right? This is the line. X is equal to -1 because it's passing through the -1 on the x-axis. All right, so what will be the reflection of this point on this line? X is equal to -1.
Now, are we supposed to be reflecting the line?
The point P, you're reflecting it on this line, x is equal to -1. That point, same point. The same point. -2. Come on, anyone else?
-4, 5.
Ryan, here is joining, going up. Ryan is always later.
Anna, network issue today, so I'm not able to join. The meeting was getting stuck.
Okay. What? Daryl, you want? Yeah, it's -4, 5. See, I'll show you. Leah said it first, then Gloria said, okay, correct. So here, this is your mirror. From the mirror, how many units ahead is this? The point P is how many units ahead of the mirror? 3 units. So you have to draw it 3 units backwards. That's where the point will be, the reflection. This is the point. So that is -4 and 5. -4, 5. So you notice when any line is parallel to the y-axis, the y coordinate did not change. This 5 is remaining as 5 only. Only the x coordinate changed, right? Okay. One last one. Yeah. How do you draw this? Actually, you draw this before I draw more, otherwise it'll just become more confusing. So here there are 2 reflections. One reflection was on the line y is equal to -2. We'll not do this one. Let's do an easier one. To draw, it will be more difficult for you. What is this line here? What's the line? Y is equal to 4. So tell me the reflection of this point P on this line, y is equal to 4. Someone? You calculate, no. See, your line is here, the point is here. This line is at 4, the point is at 5. So, yeah, so this is 1 unit ahead of it. So you'll go 1 unit behind. So here is the reflection. Right, that'll be 2, 3. Okay, we'll call this point P dash. P dash 2, 3. And this reflection on the line x is equal to -1, we'll call it P double dash. Okay, you write the question as so you draw this graph and then you mark these points on the graph. After you're done with this, question number 5 from my book. It's similar to this. You will not be using a graph paper. Just draw a rough diagram of this and plot these 2 points P and Q. Question number 5, everyone. Okay, so what is point P1, 4, 1 on the reflection of the line y is equal to 3? 4, 5? Okay, now I have to work it out, right? So y is equal to 3 will be here, correct? And the point, let me just remove all of these. Okay. Point P 4, 1, that's 4, 1 here, right? So that will be over here, correct? All right, so the answer is 4, 5. Okay, next Q minus 2, 4. Minus 2, 4. What's the answer? Minus 2, huh? 2, huh? Couldn't hear that. Be louder. Minus 2, 2, right? Okay, that is Q dash. You have to write Q dash, and this is uh, P dash. P becomes P dash, and Q becomes Q dash. Okay, now yes, you also need graphs in this chapter. If you see here all the questions here, use a graph paper, use a graph paper, use a graph paper. See here, use a graph paper for this question. Take 2 centimeters equal to 1 unit. They've given the scale. So not 1 unit, 1 centimeter. Yeah, not 1 unit, 1 centimeter. Like 2 centimeters will be 1 unit. You understood how it is? Show me one graph. Okay, here. So that means if this is 1 unit, the next unit will not be here, it will be here. Okay, leave a centimeter and make units. Now that's the type of question paper you will get in your exam. You will not get this type of graph paper. You will get the bigger blocked graph paper. Okay, where automatically 1 unit is 2 centimeters. So that's the scale that you'll be using. Okay, so draw that and then plot these points on that graph paper. Reflect all these points A, B, C, D. They're saying reflect points B, C, D on the y-axis, write down their coordinates as B dash, C dash, D dash. Then join the points A, B, C. The whole instructions are given. It's like some project work you're doing. Just see that and plot it. When anyone has any doubt, please ask. But do it by yourself. So you don't mark these empty spots. Oh,
Yeah.
yeah.
After joining the points, how should the figure look?
Afterward,
After joining the points, how should the figure look?
how should the figure?
Look.
I don't know. Let me see what everyone got. What did you get?
Uh,
What shape? Did you get a particular shape? Because they're saying name the images. Oh no, they just
Another third question.
okay. Join the points this and to form a closed figure. Write down the equation of the line about which it if this closed figure obtained is folded, the two parts of the figure exactly coincide. Okay. Third one, equation of a line you will learn later on. I don't think you'll be able to do the third part now, the equation of a line part. But just join the points and show me what shape you're getting. Okay, so the two words used often here are invariant, which is a point which remains the same even after reflection. So in this question here that we just did, which point was invariant? A was invariant because even after reflection on the y-axis, the point remained the same. Okay. Next word is collinear. That is points that are on a straight line. Your homework is to do questions from test yourself 5, 6, 7, 8, 9. This is your homework. 5, 6, 7, 8, 9. The 10th one is what we just did. Okay, so 5, 6, 7, 8, 9. You will have to use graph papers for the 8th and the 9th one. They'll mention use a graph paper. Sometimes they won't mention, like question 5, 6, 7, they have not mentioned to use graph paper. But looks like you'll have to use graph paper for that also. So if you don't have a graph book, all of you, buy a graph book. You'll be using it a lot. There are a few chapters where you need the graph book. Some chapters we need a graph book. Okay, in this unit, that is coordinate geometry, reflection, what is the first chapter that we did? In this unit, graph paper. For the rest, next two chapters, you don't need graph paper. Then in the last statistics, unit 7, there again you need graph paper in chapter 23 and 24. That is graphical representation to draw histogram and ogive. And you will draw histogram and ogive again in the chapter 24. Okay, so for 3 chapters, you need graph papers. So have a book, keep it with you. All right, we're done with maths. I hope you this chapter is clear.